All right, so here we are. I'm going to try to work with recording of page 227, problem number 34 specifically. This is in lesson 17 where we are working with changing the base formula. But in this case, actually, we are working to rewrite these expressions or the expression here at number 34 in terms of ln x, ln y, and ln z using sums and differences. So as we zoom in here on number 34, notice that there are x's, y's, and z's contained amongst this entire expression. So my goal is to take this entire natural log, ln log base e rather, which is what ln stands for, and rewrite it in terms of sums and differences, addition and subtraction problems. So what we're going to do here is we're going to rely on our properties of logarithms. Specifically, when I think of sum and difference, I think of the product property of logs. And the difference, well, the opposite of a sum is a difference. Therefore, the opposite of a product is a quotient, aka opposite of multiplication is division. Quotient is our name for division. So these are going to be our properties of logarithms here. And what these properties basically say is the following, that if we have a logarithm with an argument, like this one, that is composed of either multiplication or division, we can leverage these logarithm properties to rewrite them as addition or subtraction problems. Now notice these three things, x, y, and z to the third, those three terms all are being multiplied by each other, which means I'm going to use my product property here, product property of logarithms. So I'm going to separate this logarithm, ln, into three separate logarithms, x, ln of y, and ln of z to the third. And the reason why I can do this is because our product property of logarithm states, again, one more time, that when we have an entire logarithm with an argument like x, y, z to the third, we can work backwards and use the addition of those logarithms as individual logs. And what I mean by that is effectively, we can turn through our product property of logarithm this into a sum of three natural logs, where each part of our argument, x, y, and z, is represented here in the new arguments of our logarithm. All right, we've almost succeeded in our goal of writing this original expression as a logarithm composed of x, y, and z, except for the fact that this last natural log, z to the third, is not written in terms of ln of z, but rather ln of z to the third. By that I mean we got to get rid of this exponent. So what we're going to do is we're going to lean on one of our other properties of logarithms, and that was our power property of logarithms, as we called it before leaving school. And the power property of logarithms states that if you have an exponent, like a power of 3, in an argument, you can bring it out in front and say, all right, ln of z to the third is the same thing as 3 times ln of z. Again, what we did is we removed, notice no exponent up here, we removed the exponent 3, brought it on down in front, and multiplied by it. Now, x and y, ln of x and y didn't have this issue, so all I'm going to do is I'm going to copy and paste, bringing them on down. And sure enough, now we have succeeded in rewriting this original expression, ln of x times y times z to the third, in terms of only ln of x, ln of y, and ln of z, as follows: ln of x plus ln of y plus 3 times ln of z